Well, hello, everybody. As you know, continuous delivery is a highly debated topic. There's just so much confusion around it, right? What do we mean by continuous delivery? What might be the difference between continuous integration or continuous deployment? On top of which, there is just no one right way for any organization to implement. Um, we all have a varied view on this subject. Let's see if we can reduce some of that confusion. Please join me in welcoming our guest for today, Anders Walgreen. Anders is the VP of Technology Strategy at Cloudbees. He has over 30 years of experience designing and building commercial software while implementing CD. So welcome, Anders. Thank you so much for joining us today.
Pleasure to be here.
All right, just to take the bull by its horns, literally, what do we mean by modernizing applications?
Well, if you think about it in context, we've been doing software for maybe 60 years tops,
give or take.
So we don't really know how to do it yet. It's not one of those. It's one of those things that's as much art as science. And I don't mean that in a pretentious way. What I mean is there isn't really a method that you can go through to do this the same way every time, the way there is with manufacturing or those sorts of things, although it shares a lot of things in common with manufacturing, because one of the things you have to do in manufacturing is, okay, we've designed this wonderful thing.
Right.
We've made a prototype. Now we need 1 million of them. Right?
Of course.
That's a very different problem than here's my lovely prototype, right? But in the last, I would say 20 years especially, we started paying a lot of attention to what are the things that impact and the quality of the outcomes that we have in the software industry. And I use that sort of quality of outcomes kind of generically a little bit around, well, what are the outcomes we want? We want happy customers, we want to make money, we want to be respected, we want to have a good reputation, all of those sorts of things. But what are the things that impact those outcomes? And the way that we build, architect our software, how we maintain it, how we treat the whole life cycle, both all the way from the kind of the far left end of design and ideation, all the way through to writing the code, testing it, deploying it if it's something that you do deploy, and all the way through to then how do we service that while it's when it's in the customer's hands. We've learned a lot about these things, and what the way that we built our software 20, 30 years ago, even 5 or 10 years ago, is different because the tools that we use have changed. In the same way that if you look at a car made today and a car made 40 years ago, they're the same in the sense that they both have a steering wheel, they both have 4 wheels, they both have some sort of engine. Sometimes the engine's in the back, sometimes the engine's in the front, sometimes the engine's in the middle. But that's really where the similarities end. Cars today are traveling networks traveling data centers on wheels. There's a lot of software involved. The engines are much more complex, especially if they're hybrid. The materials that are used are dramatically different. It used to be just rubber and steel and glass, and now it's carbon and aluminum and all these other kind of materials that are much more difficult to work with. Well, software is the same, right? We've learned a lot of things about how do we store and retrieve data efficiently. When do we need data to be persistent, kind of along the ACID principles, or when is it okay to settle for things like eventual consistency and so on. And we've also learned a lot about how to run software teams. The sort of the 2 pizza team approach that Amazon uses, or the 7 plus or minus 2 in terms of how many people can work together and communicate effectively before the amount of communication overwhelms the productivity of the team. All of these kinds of things, most of which we already knew, right? I mean, they're not new to humanity, these kind of concepts, but new to software. And so modernizing applications is really about, look, if we take all of these things into account, the new tools, the new materials, the new philosophies and processes that we now know about and value, how would we build an application today if we already have one? Like if we have our monolith that, is one giant spaghetti ball of code and untested, and untested by anything but human hands anyway, not automatically tested. How would we build that today? That's really kind of the philosophical underpinnings of what we mean by modernizing applications. it obviously has a lot to do these days with, well, we would like to deploy them in containers because that we know the value of that. We would love to run it in Kubernetes because that solves a lot of the problems that we have along with auto scaling up and down and resiliency and those sorts of things. It obviously doesn't solve the problem of your application being able to scale up and down and your application being resilient, right? Kubernetes is not a magic bullet that automatically takes your crappy code and makes it wonderful, right? Yeah. But there are a lot of things that we've learned in the last 20 years. So a lot of times when we talk about modernizing applications or building applications in the modern way, we're talking about using today's tools to build applications as opposed to using the tools of 20 years ago to do it.
So you bring up two really important points, really, and I want to touch upon both while you're at it. One, of course, is the most obvious one to lends itself to the conversation, which is that, how does continuous delivery really relate to modernizing apps? So we'll take that one first before I come to the monolithic applications in specific.
Yeah, thank you for not making me remember two questions. I appreciate that. So continuous delivery, again, it's one of these phrases that you get 10 people in a room, you're going to get 12 opinions on what continuous delivery means, and because two people will change their mind halfway through. The understanding I have and that I use is really, let's look at the entire life cycle of an application, right? And that means from the time that it's a glimmer in somebody's eye all the way through to when it's in customers' hands and beyond. Right. And then let's look at that as one effort, right? That we're trying to produce an outcome where we're trying to make our customers happy, provide value to them, all of these kinds of things. What are the things that we have to do to make that work smoothly, right? To make that work so that we don't have inefficiencies, that we don't drop the ball in certain cases, that we have the quality that we want, that we have the security that we want, that we have the functionality that we want, and that we are able to deliver this in a more predictable way than software has in the past. And software has, I think, a deserved reputation for quality issues when things get out in the world. Now, I think other industries have similar, issues. Ask anybody who buys the first model year of a car, there are going to be some gremlins. No offense to the gremlin car, but we've learned a lot about these things over the years. And continuous delivery to me is, okay, how do we smoothly deliver again and again and again functionality on this application? Right, and deliver that at the business at the speed that the business demands or that the customers demand and have become accustomed to, and that's really different, because if you go back 10, 15, 20 years beyond, we were dealing then with product cycles that were 2 years, 18 months. I was running an engineering team at a software company in the late 90s, and we were on 18-month product cycles. So we literally would go 18 months between releasing new functionality to customers. And these days, obviously, people look at that and go, and you did this with sticks and stones, obviously, right? Because this must have been a long time ago. It wasn't that long ago. But for competitive reasons and also just because it yields better software, one of the things the industry has learned to do is to do things in small batch sizes. Right. And that's one of the key aspects of continuous delivery and agile. All of these things lumped together to a certain degree is don't do this big bang, massive batch release every 18 months. Try to break it down into smaller things, even if you don't deliver every single batch to the end customer, right? Because that's something that people get hung up on a lot. And especially if you deal with, say, regulated industries, right? The idea of, an engineer checks in a piece of code and 10 minutes later it's live on the website. Oh no, people go to jail if we do that, right? So the idea behind continuous delivery isn't necessarily to get it all the way out into the customer's hands all the time, but to have a cadence where you could if you needed to, right? And when I say needed to, I'm referring to things like emergency patches for bugs or security vulnerability patches or those sorts of things, to where we get good at the cadence of delivering software.
So it's the ability of the organization to
do that regular sort of delivery.
Sorry, I just was reiterating that it's essentially the ability of the organization to do this, whether you have to or not. It's just the ability to be able to consistently deliver something.
Yeah,
should there be a need.
And predictably deliver, because the other issue that you would have with these 18-month kind of batches is, nobody can predict the future 18 months ahead of time. I mean, these days the technology changes so fast that 18 months later, what you started building is no longer relevant, or you're building it using the wrong technology. So a lot of this has to do with just incremental delivery points along the way. That's agile in a nutshell, and to a large degree, I think continuous delivery as well. Just the notion that you get really good at the mechanics of delivering the software, in addition to the creative aspect, the coding aspect, the testing aspect, but just the mechanics of doing this. And the mechanics, by themselves are non-trivial for non-trivial applications. I always like to say, if you're able to do a continuous integration run or a continuous delivery run every 10 minutes, good for you. You're probably building Windows Calculator. You're probably not building Microsoft Office. You're probably not building, Google anything. You're probably, you're not delivering, significant complex applications if you can deliver all of that in less than 5 minutes. Maybe those companies can, because they obviously have vast resources to do it, but us mere humans don't have the ability to do that. But the key is, deliver more predictably. That has a lot to do with it, right? If predictably means, look, we're going to take a monthly cadence, take a monthly cadence. If by predictable that means every 2 weeks, every week, every 3 weeks, the exact details are less important than the fact that a team establishes a cadence by which they can do this predictably, and they understand all of the steps involved along the way. From from how do we have these ideas, how do we coalesce these ideas and reach agreement on them, how do we communicate them, how do we sort of write about them, design around them, write code around them, how do we test them, how do we build them, not necessarily in that order, hopefully you build it before you test it, and then get the stuff out the door, and as we've become better at doing this, a lot of these kind of patterns have shaken out. And small batch sizes is probably one of the most important ones, I think, is to not try to boil the ocean, not try to go after the sort of we're gonna build the world's best XYZ, and at the end of 18 months you're like, well, people don't really use XYZs anymore because something better came along.
Absolutely,
that's an extreme example, of course.
That's very true. Now, coming back to, as we're talking about modernization of applications, most organizations, everybody has to start somewhere, really, right? And so, of course, you start with some monolithic applications to begin with. So it begs the question, can we use continuous delivery for monolithic applications? I'm pretty sure most of us have that question in mind.
Absolutely. And I think the answer is yes, right? But I think you have to understand, too, some of the limitations that you deal with. So if we take the example of, we've got a large monolithic app. It's probably some number of years old. Most of the people that started working on that application may no longer be working on it. They may no longer be at the company, et cetera, et cetera. Sort of all the challenges, or some of the challenges that you have when dealing with what if it was untestable software, not automatically testable software, I would refer to as legacy software. If it's automatically testable, then I prefer to use the word heritage, because legacy has become such an ugly word. But you still can do a lot of things, right? Now you're limited by, if you're going to deploy anything, you have to deploy everything. If you're going to ship anything, you have to ship everything. So there are some limitations around the architecture of a monolithic application, because it is by its very definition one big chunk, right?
Right.
But you can still build automated building, automated continuous integration, continuous testing, continuous delivery pipelines for the application, so that whenever you have a change to the code, that you can kick off a CI pipeline. If that CI pipeline successfully completes, you might kick off a further, more sort of a continuous delivery or a release pipeline to do more integration testing, system testing, security testing, whatever kinds of things you need to do. The key thing to understand about this and how you work to achieve something like continuous delivery with a monolithic application is you're in the same boat as everybody else, which is you have to understand your process, right?
Right.
And at some point, you got to get everybody, all the stakeholders, ideally in the same room, although obviously these days that's a little bit difficult, but in kind of in the same location, at virtual or not, at the same time, and really understand what are all the steps that we take to get the software out the door, and then work to, at its very simplest level, understand what that looks like. That's something value stream mapping is an exercise that people use very often to kind of discover that. And then they use that sort of value stream mapping to come up with, hey, what are the pipelines that we need for this, that, and the other, and give everybody kind of the same bird's eye view of the things that have to happen to get the software out the door. The main difference with a monolithic application versus, say, a microservices-based or loosely coupled application is you can have one set of things that you do, whereas that applies to the whole code base. And at least in the beginning, whereas if you're dealing with a sort of a mature, loosely coupled or microservices-based application or ecosystem, you're going to have lots of different pieces with their own kind of life cycles and their own development tools, their own pipelines, all of those things, which is a little bit of the state of nirvana that you want to get to, but which also present challenges, because anytime you have 10 of something as opposed to one of something, it gets more difficult. As I like to point out, one of the nice things about a monolithic application is when something goes wrong, you know what broke the monolith, as opposed to I've got 500 microservices and a customer just called in with a bug. Where do I begin,
Right. So now we've spoken about both, monolithic applications as well as loosely coupled or microservices for that matter. In your experience, what would be the best advice that you would give, Anders, on organizations undertaking modernization, irrespective of what applications they have? It could be specific to applications, certainly, but, in general, what's the best advice you would give, given your experience in the field?
I think one of the first things that I look for, if a team is, let's just posit a situation, right? We've got a monolithic application, so sort of one code base, even if it's a client server application, right? It might have, business logic and UI separate, it might be well architected kind of monolithic application. But one of the first things that I would encourage people to look at, especially if you want to modernize it and make it more loosely coupled, if you want to go in the direction of microservices and so on, which obviously is a very hot topic these days and deservedly so. One of the first things I encourage people to do is look at your data model, right? Because it's one thing to go after your code base and decouple that. That's actually, while non-trivial, it's a very achievable thing. The challenge is you may get to the end of that effort and find out that you have so much coupling in your data model. So for example, if all of your data is stored in one database instance, one RDBMS instance, and you've got foreign keys between different tables, that's a form of coupling that will inevitably show up in your code. Especially if you're using things like object relational mapping tools and so on, these entities, which is kind of borrowing from the Hibernate technology, these entities have to show up somehow in your code. So it's not necessarily as simple as just refactor the code, because you may have to refactor the data as well, or know where you don't want to refactor the data because you may have so much of it that that's not realistic, or have various other constraints. So I would say and certainly my first kind of instinct as a software engineer is well, let's go look at the code. And you've got to, also keep in mind that, go look at the data as well, because the coupling in the data will be often more difficult to undo than the coupling in the code, because quite frankly, IDEs and development environments for code are so good these days at giving you dependency matrices and giving you refactoring tools that, the old days of, when you had to rename a class, you had to go edit 50 files manually and it took you all night. That takes 10 seconds or 5 seconds today. So it really comes down to, look at don't forget to look at the data. That's my biggest piece of advice, because that you will find some of the hairiest problems that you'll need to solve in the data model.
Okay, that's fair. That's absolutely fair. So how would an organization looking to undertake this journey of modernization for their applications? I mean, what's the benefit that, say, continuous delivery in this context could provide to the organization? How would they reap some of those benefits?
So let me answer that with an anecdote, because one of the interesting experiences I had a few years ago was listening to a talk by this gentleman named Scott Prue, who works for a company called, I think it's CSC, but I forget. The thing you need to know about what Scott does is he runs a group that does a lot of mainframe development. And they actually brought continuous delivery, DevOps, to the mainframe. And he tells just a very compelling story of one of the first things we needed to do. And this was actually probably even, a smaller level goal than sort of DevOps or CD. It was, how do we bring a little bit of continuous integration to our mainframe code base? And they started out by just writing 5 tests. They just wrote 5 tests. And that was the beginning of, you know what, every time we make changes to the code base, we're going to run these 5 tests, and they chose wisely, and those tests were useful in discovering problems and those sorts of things. But the idea is, start somewhere and figure out, and a lot of times you have to think a little bit about kind of where your pain points or where your challenges are. If you have a large code base that's manually tested, right, you're in a bad place. I'm not going to sugarcoat it. If all of your testing is at the end, and when you have a bunch of humans clicking and pointing at a screen, you're in a world of hurt. You need to address that problem. But you can address that by starting just 5 tests. Just start somewhere, and start to have a little bit of a cadence, right? And the first time that you turn the crank on this machine, it's going to go slow and it's going to break, and it's you're going to have fits and starts. But it's very important to just kind of start that cadence of, every time we check in, we're going to run these 5 tests. And then the next week it's 10 tests, and the next week it's 100 tests, and well, maybe not the next week, but you kind of eventually get going to where you have, because one of the things you're going to do when you take this monolith is you're going to use some sort of pattern, like the strangler pattern, for example, to squeeze out functionality out of the monolith and maybe place it in a separate service or a separate code base at least. And you need to make sure that the thing still works as you're doing this, right? So if at the end of that you need 6 weeks of manual testing, like I said, you're in a world of hurt. So if you can then focus on, let's build some tests around the first service that we want to extract, right? Build some tests, make sure that that's working, and then write those tests. Ideally before you start the refactoring of that code, and you have to have very modest goals. You have to have very focused goals, and just because if you try to just boil the ocean, if you try to just say, well, we're just going to start with a fresh sheet of paper. I mean, in some cases that you have the freedom to do that, but not often. It's not often that you get to, pull over by the side of the road to fix a flat tire. You really don't get to do that. Really, what we're being asked to do a lot of the time is, while going full speed on the freeway, change the engine out. We really don't have the luxury of saying, well, we're not going to do any more software development for 3 years while we engineer our application from scratch. You tend to, for various business reality kind of reasons, you have to work on this thing while it's going, and that in itself is a little bit of a challenge. But start small, have modest expectations, have very small goals. But the important thing is get that wedge in there, get that piece of automated testing in there, get that little piece of automation stood up if you don't have any, and just start from there and build on top of that. I'm addressing that problem as if an organization has no automation around this, which sometimes and frankly often is the case still these days. But we're all on a spectrum here in terms of how much of this we're already doing.
That is so true. Well, this has been insightful for sure, Anders. I mean, I do want to thank you for your time and the insight that experience brings to the table, having done this for 30 odd years. So thank you so much for your time. I'm hoping that everybody who sort of listens to this comes out of it with an understanding of what are some of the basic pitfalls, what are the best practices, if you will, things that you could do in order to implement continuous delivery and get on the bandwagon, if you will. Well, thank you so much for your time today. This has been great. Thank you.
My pleasure.